Good afternoon, everyone. My name is Alan Meadows, Cloud Architect for AT&T.
And I'm Pete, one of the developers working on OPENSTACK-HELM.
And I'm Vinay Rao. I am from Juniper Networks, working on Tungsten Fabric-helm.
And we're gonna provide a telco next generation stack update today for both OPENSTACK-HELM and Tungsten Fabric-helm. So the agenda is we're going to keep this really brief because we've done this many times before. A brief introduction to Helm in case anyone here is not familiar with it. An AT&T usage update, how we're leveraging OPENSTACK-HELM internally, and also an OPENSTACK-HELM project update, effectively where we've arrived since Sydney. That's the focus. And then finally, Vinay is going to give us a Tungsten Fabric-helm update as well. So again, this is going to be pretty quick, just in case anyone in the room is not familiar with Helm yet. What is Helm? So probably most simply put, Helm is a package manager for Kubernetes. It helps you define, install, and upgrade even the most complex Kubernetes applications using Helm charts. Chart is a collection of files that describe a related set of Kubernetes resources. Helm wraps up each of these charts into concrete releases, effectively tiny little boxes that are collections of all the Kubernetes resources that compose a particular service so that you can interact with that collection as a single unit, whether you're installing it, upgrading it, updating it, or deleting it even. At its core, the value that it brings for us is that it allows us to templatize our experience with Helm so that high-level software orchestrators or administrators have a standard interface for them to be able to operate Helm charts, provide inputs that are specific to their environments, and things like that. OPENSTACK-HELM is essentially a marriage of Kubernetes, Helm, and OpenStack. It seeks to create Helm charts for each OpenStack service. These charts provide complete lifecycle management for these OpenStack services. So again, there's a really important emphasis on that. It's not just about installing and standing up OpenStack. It's about managing the life cycle of those OpenStack services. So really caring for it beyond just simple, basic installations that people don't intend to touch in the future. So users of OPENSTACK-HELM either deploy all or individual OpenStack components along with the required dependencies, and it heavily borrows concepts from Stack and Eddies and other complex Helm application deployments. And ideally, at the end of the day, this project is meant to be a collaborative project that brings OpenStack applications into a cloud-native model. So our vision for OPENSTACK-HELM is that we want to streamline the standing up of OpenStack applications within Kubernetes. But not only that, we want to ensure that we're enabling the upgrade and updates of those OpenStack installations and their dependencies, whether those are, and this is an important point, whether those dependencies, or whether those are the actual OpenStack services themselves or dependencies such as Ceph, MariaDB, Memcache, all the other OpenStack services as well. And finally, we want to ensure that we provide operators the capability of maximum configuration flexibility, while at the same time they can choose as few or as many of the OpenStack ecosystem components as they want to build their clouds. And finally, who contributes to this project? So there are a number of OPENSTACK-HELM contributors. We don't have space to mention them all. I think it's worth pointing out AT&T, SK Telecom, 99 Cloud, and Nokia. And a brief update of where we were in Sydney. So in terms of the basic services, all of the core services, things like Nova, Neutron, Cinder, and so on, were working in the sense that you can install them, and they functioned. Not only that, but over several sessions, including a Sydney keynote, we demonstrated upgrading these core services in OPENSTACK-HELM from Mitaka to Newton using what is now an OpenStack project under the Airship umbrella Armada in order to declare and orchestrate multiple Helm charts, including the ability to upgrade from one version to another very easily. All of this made possible by the underlying capabilities provided by OPENSTACK-HELM itself. Also back in Sydney, all the ancillary services, so the infrastructure required for Helm itself, things such as MariaDB, Memcache, RabbitMQ, and so on, they were installable. Many of them were upgradable, but we had not really tested that functionality through and through. In terms of network functionality, we were able to run both Open vSwitch and Open Contrail at that time as solutions for OpenStack-HELM. And finally, out of the box, the version of OpenStack that you got, if you were to grab OpenStack-HELM at the time of Sydney, was Newton in terms of what it would deploy. So I'm going to hand it over to Pete, who's going to dig in a little more of the details in terms of what's changed since the last summit.
Okay, thanks, Alan. So quite a bit has changed in OpenStack-HELM since Sydney, but simultaneously stayed the same, in the sense that the core sort of API and interface for deploying and managing these charts has stayed the same, although internally they've actually altered quite a bit as we've gained experience, as we start moving towards full deployment and management of these systems. So firstly, we brought in dynamic configuration and dependencies so that we can run multiple jobs if we want to in advance of actually bringing up the chart. For example, pre-pulling images and storing them within a local cache within the cluster. For Neutron, we enable you to disable or enable different agents or other host services that you might want to deploy if you're running multiple agents or networking backends. And then we've also allowed this to be extensible because every organization has its own specific requirements and other ancillary services that everything calls on, which we allow you to integrate quite easily. The other thing that we've really sort of strived to get is consistent patterns across charts. So we've been able to take a bit of a step back and actually sort of start pulling out commonality between various OpenStack and non-OpenStack components, the most obvious examples being things like the keystone management jobs and database synchronization and initialization jobs, where these have been taken out from the charts themselves as verbose templates and embedded into our common library, which we refer to as Helm Toolkit, which can be then called upon by any service that wants to use them. Then, once we've actually got these services up and running, we've now introduced some cron jobs for performing basic maintenance tasks, the most pertinent of which is probably things like Keystone Fernet token rotation, so that once you've actually deployed this, it will start looking after itself and require minimum operator intervention to keep running. And then Keystone Engine cleanup, Heat Engine cleanup, so that when we perform upgrades, the old engines are removed from the database. And then other ones for doing things like Cinder usage auditing. There's been a lot of operator feedback, which has really driven some of these changes, which you might want to touch on.
Yeah, I think a great example of an incorporation of operator feedback. Again, at the end of the day, we're actually leveraging this in-house at AT&T for our 5G core platform. And so one example of this is investigating, doing troubleshooting for Open vSwitch and Neutron. I think this is already a struggle for a lot of people. Doing this in a containerized environment becomes an especially difficult challenge. And so one of the things that recently changed there is taking the namespaces that are generally fabricated inside of the L3 containers and ensuring that those are pushed into the hosts themselves that are running those containers. And that greatly increases end users' ability to go ahead and do standard troubleshooting steps like dipping into certain namespaces and trying to troubleshoot networking issues and things like that, because it's a familiar way to interact.
Yeah, and I think that really touches on how we've been able to embrace new Kubernetes features as they've become available to us. When we started out on this project looking at the Kubernetes roadmap, we felt that Kube 1.8 was sort of the minimum viable version of Kubernetes to support all of the features we were looking for. But then with 1.10, we had the ability to do mount propagation into the containers, which enabled things like the network namespaces to be propagated back to the host, which has Alan points out, is really great from a debugging and operations point of view, where we have an OpenStack deployment that looks relatively very normal to a lot of operations people. And the other thing that we really sort of concentrated on in the intermediate time between Sydney and now was getting production-ready ancillary services. So one of the sort of most low-hanging fruit there, but sort of what made one of the biggest difference, was putting MariaDB behind a Kubernetes ingress controller, which means that we don't suffer the risk of database deadlocks with high concurrent writes and a multi-master configuration. So it's very small changes like that really give us a much more resilient solution. Additionally, RabbitMQ and many other applications are now becoming Kubernetes aware. So with the release of 3.7, we're able to use the auto clusterer support there to really give us a very resilient Rabbit deployment. Furthermore, we've done some work in the Ceph space where we've been working quite closely with the Ceph-HELM team over in their repositories, and working and splitting out the chart into 3 components. One which deals with the Mons, the other for the OSDs, and then a third one that has all of the clients of Ceph itself within. And this allows us to really take control of that deployment and upgrade components in a very similar manner to you'd get with Ceph Deploy or another supported deployment methodology. And then, as well as the actual improvements within the charts themselves, we've been able to validate this through much stronger gating and CI than we originally had. This has both been used for Cola and Loki images to make sure that we don't end up going down to an avenue where we lose that sort of image agnostic goal that we have. And we're now gating on Newton, Okata, Pike, and there is a Queen's patch set that's about to merge, which really has sort of demonstrated that this is one set of charts that can deploy multiple versions of OpenStack and manage that life cycle through them. And additionally, we've had quite a lot of work going on, again, sort of in the getting everything more towards a production-ready state in the logging, monitoring, and alerting state.
It works.
Yeah.
So maybe a couple of things to point out that are now available out of the box is effectively just deploying OpenStack-HELM. You can get things such as FluentD, now collecting all of your logs from containers, Elasticsearch, but now configured in a way that really is closer to a production configuration. In other words, we're rotating the indices and making sure that the space that we're dedicating to Elasticsearch is not filling up. So some of the sort of logging, monitoring, and alerting, hardening sort of stuff that's going on. There's also a Nagios chart out there that integrates with the statistics coming out of Prometheus, sort of allowing the old and the new to sit side by side. So although Prometheus is now the engine for collecting all that information, a lot of organizations, us included, are still tied to a Nagios world. So instead of re-implementing all of those checks again in Nagios, Nagios just leans on Prometheus to get that data and raise those alerts, and that interacts with a lot of folks' classic internal systems to raise those alarms up. And then finally, Grafana is there, but it's not only there in terms of just being there. As soon as it's installed, it comes out of the box with dashboards in order for you to view the current status of Ceph, what's going on with the OpenStack cluster itself, and what's going on with Kubernetes in the various nodes. So highly useful and functional now, just installing it without touching anything else.
And part of that was rewriting or writing from scratch a OpenStack exporter for Prometheus, which is currently open source within the ATT ComDev repos, and we will hopefully find a home in OpenStack quite soon for.
Yeah.
Okay. So I think we're now at a stage with OpenStack-HELM where we're getting relatively quite close to what I think we can regard as something stable for a 1.0 release. There was quite a lot of work required to get there in terms of standardizing on our Helm toolkit library, because at some stage in our development, the multiple repositories we had become quite divergent. but that's now completed. And this then allowed us to sort of push through standardization across all of the charts in a really sort of quite rigorous way. So they're now looking pretty good in the sense that if we make a change to one, we can then roll that out across our entire fleet of charts pretty simply. What we still have coming up, which is sort of fairly big in that, is we need to define our release process. Back at the OpenStack PTG in Dublin, we tried prototyping this out using sugar cubes on a table where we envisaged a point at which our charts would no longer be able to accommodate an OpenStack release. But both fortunately and unfortunately, right up to master, we're finding that what we have today is suitable for operating and deploying OpenStack with some configuration changes. And this then touches on the fact that one of the other things that we need to get in place before we're prepared to cut a 1.0 release is actually validating this upgrading, because although we've both demonstrated it and use it internally, and I know other people externally are using it quite a lot as well, we need this gated and running in OpenStack infra so that we know that any change that we make to any part of OpenStack-HELM isn't going to have a negative impact. And then probably the most painful point that's left for us is documentation. In some ways, we're actually quite pleased with the documentation we have today, because we're one of the few OpenStack projects which is using its gating environment to generate its documentation. So we're very confident that at any point in time, the documentation that we have is current and will allow you to deploy and operate OpenStack-HELM. But it is really incredibly terse and lacking explanation for a background of a lot of the decisions that we made and a lot of the sort of day two operations and troubleshooting procedures that I think are really required to make this operational. And I think with that, it's probably quite a good segue to talk about how it's used within AT&T.
Yeah. So we've talked a lot at this summit so far about AT&T and how we're leveraging Airship and how we're using OpenStack-HELM as part of that as well. And so it's worth briefly just touching upon how a company is using this internally. So AT&T's network cloud is based on Airship. It's an umbrella for several OpenStack projects that were recently placed into the OpenStack Foundation. OpenStack and Airship are very much related projects in that they both leverage Helm as their fundamental deployment mechanism, and Airship leverages OpenStack-HELM as the Helm mechanism to deliver OpenStack clouds. So Airship itself is a collection of interoperable and loosely coupled and nautically themed open source tools that provide for automated cloud provisioning and lifecycle management in a completely declarative and predictable way. And again, those last two comments there are really important. Declarative and predictable are really fundamental for what we're trying to deliver with Airship. All of the Airship components help us manage sites, from their creation to minor updates through configuration changes, and finally, major software uplifts such as OpenStack upgrades. And really, the power of that is delivered by OpenStack-HELM under the hood, at least in terms of OpenStack itself. And so the focus of the project has been the implementation of a declarative platform to introduce OpenStack on Kubernetes and the lifecycle management of that cloud. And so Airship is really trying to be an end-to-end solution for Kubernetes-based OpenStack deployments, because where OpenStack-HELM sort of begins, Airship is really attempting to get us all the way up to that point so that we can start leveraging that and really make that a fruitful combination. So Airship and OpenStack-HELM are being leveraged by AT&T's 5G core platform today. We've already deployed or had several successful deployments that are being actively used by VNFs on this platform, and we're successfully updating those live environments using Airship's lifecycle management today. And so I think, again, briefly, it's just worth looking at what AT&T's layer sort of looks like and what an Airship cloud looks like under the hood, and how that relates to OpenStack-HELM. So Airship is going to care, first before before I start jumping up the stack, Airship is going to care for each of these components that we're going to look at. And so we're going to start at the bottom and sort of work our way up. There's a bare metal host, and that host operating system and network and storage configuration is something that's declared in Airship and laid down by DryDock, which is a declarative bare metal provisioning engine inside of Airship. And finally, Promenade, another project in Airship, handles effectively two aspects of Kubernetes management. The first is it handles Docker, the Kubernetes cluster and its lifecycle. And the second is that it handles the Docker and kubelet configurations on each of the hosts, as well as joining them to the cluster and labeling them appropriately so they receive the right workloads. Airship instantiates Ceph and Calico, among other infrastructure, using Helm charts, all orchestrated by Armada, all within the undercloud to provide storage and networking capabilities to Kubernetes. And all of the Airship components themselves are installed and maintained as Helm charts as well. So finally, the OpenStack-HELM is leveraged to provide a fully functioning OpenStack installation, as well as logging, monitoring, and alerting. And the entire stack is installed and lifecycled the same way, including Airship itself. So again, sort of to sum it up, everything that you see on the screen, every layer there is cared for by Airship, leveraging OpenStack-HELM for installations and updates. And I think with that, I'm going to pass it back to Pete to give us another quick update on OpenStack-HELM and how it's relating with the other open source projects out there.
So, I actually think it was around about the time of Sydney we became an official OpenStack project, which has really allowed us to sort of start working across with other teams much more tightly. However, there's still quite a deficient gap in the form of stickers, which I believe we're waiting for. So what this has sort of really allowed us to change is the general approachability of OpenStack-HELM, where we started to work, obviously with Juniper for some time on both Contrail and Tungsten Fabric now, and with the Ceph community as well, who have adopted many aspects of our deployment methodology and management, where we feel that we've kind of, if you can manage OpenStack with the patterns that we've produced, you can probably manage a lot of other complex applications as well, using the same dependency model that we lifted from Stack-Kubernetes and then refined further and put into a Helm world. Additionally, we've been working with other OpenStack projects, mostly in the form of Loki for image builds, which allows us to have a very tight turnaround between OpenStack code being produced and us being able to deploy it into a cluster or test it. And then as well as obviously the Airship components, which have been leveraging OpenStack-HELM's methods for charts deployment and management. And finally for Calico, we've been working a bit upstream there in order to try and sort of preach the idea of using Helm charts for CNI deployment and management. Okay.
Cool. Yeah. We're going to pass it over to Vinay to
and to discuss some of the stuff that's been going on in Contrail.
Yep. So for the next part, I'll quickly give you what the updates from the Tungsten Fabric-helm project, what's happening up there. So back in Sydney, right, that's the first time we introduced the whole construct of an open Contrail Helm charts. And we did so at that point, all the open Contrail components were containerized, they were working, they were upgradable. We demonstrated using Helm and hitless upgrade, that's from Mitaka to Newton. We demoed how you could use a integrated OpenStack-HELM with Tungsten Fabric-helm to do some dynamic VNF service chaining. And at that point, we were working with the OpenStack-HELM community to run, to support Newton as the OpenStack version, right? But while we, from Sydney to here, Vancouver, quite a few things have changed. The first thing that happened is, we evolved our project. So back then, we were OpenContrail, which was an open source SDN solution to solve key networking challenges in the cloud space. But at that point, we decided that we took our project to the Linux Foundation, and we evolved OpenContrail to Tungsten Fabric. So what Tungsten Fabric does is it is an ubiquitous SDN controller that solves key networking challenges across different types of workloads. Yeah, you can use the same SDN controller to solve your bare metal, SmartNIC. You could have VMs running on OpenStack, or you could even have workloads running in your PaaS environment like Kubernetes. And everything can be seamlessly controlled via a single SDN controller. And the whole goal of this Linux Foundation SDN controller is to run all your applications through an intent-driven process, right? So you basically decide and provide an intent to the controller, which sits in the center of the architecture, and it can control multiple different endpoints, that the policy enforcement endpoints that reside in a variety of different environments. And through this, you can actually have a seamless network and policy definition across all the different infrastructures that you are running, right? So that is what we did by evolving our project and bringing it to the Linux Foundation, because we felt that's where we could bring the value of an SDN to the Linux Foundation community. But along with that, right, we just did not evolve in giving the project as is to the community. We thought as we are evolving to this whole cloud-based architectures and stuff, we should evolve the architecture also of the product, right? So for guys familiar with OpenContrail, we started way back with the OpenStack community, right? And the way OpenContrail worked back then was that we ran services or daemons on bare metal host or in a virtualized in a virtual machine for the SDN controller, right? And then back when we were trying to work with the OpenStack-HELM community, the first thing that we did is we actually containerized all our components, right? We ran all our analytics, control components, config components in different containers, but there was still a lot of different daemons that were actually stuck together to make a fat container. So when we started thinking about evolving and going to a very cloud-native architecture to the Linux Foundation, we thought, why not move from a containerized-based architecture to a more microservices-based architecture? Now, you guys may wonder, why is this so important, right? So the thing was, we actually, as we move to a microservices-based architecture, right, it gives us the flexibility to use Helm, right, or to use the actual infrastructure to upgrade some of the components without really bringing down the whole system. So it gives you a more flexibility in your lifecycle management, and you can decide which and what part of your component you want to actually evolve at a particular given time. Now, when our project evolved and the architecture evolved, we also actually evolved our charts, right? So if you look at this, on the upper side of the x-axis, you will see how we started way back when we did our demo in Sydney, right? We had two charts that we named as the OpenContrail controller and the vRouter, right? But as we evolved, we actually decided that we could break down our OpenContrail controller chart to a few more charts, right? So now, based on different types of roles, we've actually divided our charts to the controller, the analytics, the third party. The third party is like the ancillary services, and finally the vRouter, right? What it means is all your config components and your control components reside in the actual controller chart, and you can actually update the chart by itself, or you could update the daemon set by themselves, right? And similar aspect, we can actually update or upgrade different parts of the analytics by itself without really touching the controller. The third party is, of course, any changes that come in the third party tools that we use. We can easily incorporate those changes without really touching the rest of the parts of the components. And finally, the vRouter. So there's one important thing to note over here. Back in Sydney, when we first evolved and had the first version of OpenContrail-HELM, at that point, we supported only the kernel mode vRouter, right? But as we were evolving to the Tungsten Fabric-helm, right, we also wanted to bring in the support of a DPDK fast forwarding mode. What it means is the Tungsten Fabric-helm that's present today can natively deploy a vRouter in DPDK fast forwarding mode. That means you can run your VNFs in the fast forwarding mode and get better performance instead of if you did not want to run in the kernel mode, right? Now, so as we have evolved the project, the architecture, and the charts, what does it mean from the functionality perspective that Tungsten Fabric brings to the table, right? So as the features, as the entire community and the community evolved, right, the current code base actually supports some very key features that can be used across different platforms, right? We have supports for remote compute, where you could run your architecture in distributed fashion and have seamless connectivity with them. We support vRouter to vRouter encryption. So we understand that as you start going into a distributed architecture, you need to secure your traffic. So all our traffic, you can run vRouter to vRouter encryption, right? We have enhancements for fast flow. So as you go to 5G and other applications and you have fast flows, we support that natively in the vRouter, right? We support hybrid cloud architecture. When I say hybrid cloud architecture is a single SDN controller controlling your IaaS, PaaS, or any sort of workload, whether it's residing on-prem or whether it's residing in public cloud, everything can be seamlessly policy defined from a single point controller. The point I've already brought up is there is an entire intent-driven policy framework present natively in Tungsten Fabric control. And thanks to OpenStack community, we are now at the Okata release of OpenStack. That's what we are supporting. We are also working with the community to start working on the upcoming newer releases. Another important feature is gateway-less forwarding. So this is something important to note, right? Once we go to the SDN architecture, people believe that we really require an SDN gateway to actually, at an endpoint to do your north-south connectivity and stuff. The latest release or the latest code of Tungsten Fabric actually supports gateway-less forwarding, wherein you really don't need to have an SDN gateway to do any forwarding, right? You natively, your VNFs or your applications running and managed by the SDN controller have the capability to reach and leverage the internet without real any need of any hardware, right? There are a few things that you need to enable from a networking perspective on the controller, but other than that, nothing else. And of course, last and important thing, thanks to the OpenStack community, again, we've enabled all our patches through an upstream gate, which is similar to the OpenStack community today, right? Now that we have enhanced, we've come up with the new features, right? There are some things that we are still working on, and that's something which I want to present at the next slide, right? So the things that we couldn't get ready by this summit, or things that we are working on, is one and the most important thing is all the update that I provided until now, the Helm charts and stuff are residing with the Tungsten Fabric namespace and Linux Foundation. What we are working towards today is basically moving these Helm sort of entities from the Tungsten Fabric to actually bring it to OpenStack-HELM, where what we believe is the true home for these charts, right? Another aspect is we're working on some features to actually run Tungsten Fabric as the OpenStack-HELM infra. In fact, that is what is the underlay before you bring up the OpenStack Cloud. So if you looked at the slide that Alan and Pete presented some time back, you saw that the SDN layer was talking only at the OpenStack level. But what we are also looking at natively using Tungsten Fabric as a CNI to actually connect the entire Kubernetes workloads, right? There are some more enhancements we are working on so basically we have the DPDK vRouter, and we saw that the OpenStack community supports SRIOE. So we are trying to work on having the DPDK and SRIOE coexistence. That's actually in work in progress. We're moving to an evolved Neutron ML2 plugin architecture. And finally, and the most important thing that we want is a cross-community kind of collaboration. So you have the Tungsten Fabric community, which is doing wonderful work in building the SDN controller, but we really require some help from the OpenStack-HELM community to leverage on some of the work that we are doing so that we can get some of the benefits of both the communities. So with that, I had just one slide. OK, just one slide to quickly tell you, if you guys are looking at where to start, what to do, this is where you'll find all the material for OpenStack-HELM. And of course, if you want to find out more about Tungsten Fabric and Tungsten Fabric-helm, that's the tungsten.io. It's a Linux Foundation place where all our project material is placed. Last but not the least, I wanted to thank my colleagues Madhukar and Kasim, who've done a lot of the heavyweight lifting for all the charts that are present in Tungsten Fabric. And with that, OK, this is one thing, right? So I just made a quick slide of all the Helm sessions that have been at this summit. In case you have missed any, most of them are recorded. Feel free to go and see all the videos. Of course, you can even go onto YouTube. And if you just type in OpenStack and Helm, you'll find tons of videos to give you more information of what the project is, how things are working, and stuff. So with that, we open the floor for any questions. Sure. So if you don't mind, can you go to the microphone because it's recorded?
Yeah, Parviz Yagani, Future Way. Could you go back to the slide showing the Acrano in this project? There was a big circle with a bunch of projects, including Acrano and Airship.
I think that was another deck from another presentation.
Oh.
Was it in there?
Yeah, this.
Yeah, it was.
Just before that Tungsten Helm.
Oh, so many slides.
OK, yeah.
Here you go. OK.
Yeah.
All right. So you are showing Acrano and Airship, and then you are showing the fabric. In the bigger picture, Acrano is an edge cloud, which would probably bring like a linkage to something like ONAP as an orchestrator.
So this picture is effectively there to just represent the other communities that OpenStack-HELM itself is having an impact on at the end of the day. Yeah. And so one of the things that Acrano is looking at is potentially leveraging Airship as the undercloud provisioning framework, and part of that is also leveraging OpenStack-HELM. So there's a linkage there in the sense that there's a relationship and an impact there in terms of what they're using at the end of the day.
Yeah, my question is more on this gentleman, the last speaker. Sorry, I forgot your name.
Vinay.
Renee, OK. You mentioned the intent-based application that you can leverage the fabric. Yep. Intent, to me, is a much higher layer.
Yes.
But there has to be some vertical stack in between.
Yes.
That you can push your intent, and you
Correct.
go through some software layers that you translate into something that is consumable by your orchestration stack.
Correct.
And eventually you go down to the Vim layer and you bring the fabric in.
Exactly. So if I can go back to the slide where I spoke about it in a second, and that's over here, right? So if you look over here, from an SDN control perspective, right, we give you the APIs to define the intent, right? As you pointed out, definitely the intent for an SDN controller comes from a not-bound orchestration system. In the Helm or in the OpenStack world, the not-bound orchestration system that provides the intent to the SDN controller is OpenStack itself, right? It tells that I need the network, I need to connect workloads across different sort of domains and all those things. So from a policy perspective, so what the SDN controller does is basically it understands the intent and it knows the different endpoints where the intent has to be rendered, right? Now, if you had a hybrid or if you had a different sort of workloads, right? If it's very important that a not-bound orchestrator that is providing an information, the same intent needs to go to everything that it is managed, right? And that is where I was telling you that the Tungsten Fabric controller is bringing the intent provided by the consumer is deployed and
not directly. My point is that the intent, is not really consumable by the network layer. Intent has to go through a process of mapping into a recipe or something like in the nature of consumable by your orchestration layer.
Yes.
But where is that here?
So if you look at it, the controller that is sitting over there on the northbound is actually listening to the intent that it is receiving from the orchestration system above it,
Okay.
the UI, the apps, the OpenStack, and other
Correct,
orchestration system. So the definition and the driving of the intent is done by those applications. The network controller is actually just taking that intent and rendering it across different
And the
endpoints.
modeling is done by somewhere else?
So the modeling is actually done. So the intent is provided, and the SDN controller understands the intent, models it, understands where it has to be actually rendered to, and then renders it seamlessly.
I take it offline.
Yeah, sure.
The application modeling will be done by ONAP. Yeah, exactly. So we will drive both the OpenStack and sideband, because some of the guys are not fully integrated, like service function chaining, to the SDN controller, right? So if you're looking for the application modeling component, that would be the ONAP or its
Sorry.
Okay.
I think we're being asked that we're out of time. Sorry.
Yeah, sure. Okay, thank you guys.
Thank you.
Thank
So
you.
we have few of the Tungsten Fabric stickers. So as you leave the room, please collect it. Thank you. Yes, out here.